guys, so I'm going to go through your surds homework for you. Right, so question 1 was simplify each of these surds. So the first one we've got is the square root of 18. So we know that we take our 18 and we are looking for the factors of 18. So we have 1 and 18. Next we would have 2 and 9. And remember what we're looking for is we're looking for the biggest possible square number we can. So 9 is a square number and it's the biggest one we're going to get. So we're going to get the square root of 9 times 2. So that splits up as the square root of 9 times by the square root of 2. So we get 3 root 2 because the square root of 9 is 3 and we just leave the square root of 2 as it is. Okay, so next we've got the square root of 12. So again we're looking here, so 12, we've got 1 and we have 12. We've got 2 and we have 6. Each of these times starting looking at 1 times, then 2 times, then 3, then 4, then 5 until you find the square number. So 1 times 12 is not going to help us. 2 times 6, neither of them are square numbers, and then we've got 3 times 4. So 4 is one of our square numbers, there we go. So split it up into 4 times 3, and then again we've got the square root of 4 times by the square root of 3. So we get 2 from the square root of 4, and we just leave the square root of 3 as it is because that's the surd in its simplest form. So 27, we've got 1 times 27. Because it's odd, it's not going to be in the 2 times table, so that's not going to be there. And then it's in the 3 times table, and it's 3 times 9, so we find our square number. So we have the square root of 9 times 3. So that is the square root of 9 times the square root of 3. The square root of 9 is 3. The square root of 3 just stays as it is. There we go. Right, so 50. We've got 1 times 50. We would have 2 times 25. And 25 is our square number, so we found our biggest one. So square root of 25 times 2. So it's the square root of 25 times the square root of 2. So the square root of 25 is 5, the square root of 2 is just the square root of 2. There we go. Right, so magically E, F, G and H have appeared. So let's go on with E. So we've got 45. So we've got 1 times 45. It's not going to be it. It's not in the 2 times table because it's odd. 3 times table, yep. It'd be 3 times 15. But 15 is not a square number. 3 is not a square number. Keep going. Because it ends in a 5, we know it's going to be in the 5 times table. It's not in the 4 times table. So it's going to be 5 times 9. So we have our square number. So we're going to have 9 times 5, and that's square rooted. So we have the square root of 9 times the square root of 5. So the square root of 9 is 3, and then the square root of 5 just stays as it is. Okay, so hopefully we're getting the hang of these by now. 20. We've got 1 times 20. We would have 2 times 10, still no square numbers. It's not in the 3 times table. We have 4 times 5. And because those are really close together, that's all our pairs, so our only square number we've got is that 4. So we do the square root of 4 times 5. So the square root of 4 times by the square root of 5, because we split it up, so we get 2. Square root of 5 stays as it is, so we get 2 root 5. Okay, so now on to G and H. These we have to add them together. So first, we need to figure out what the square root of 8 is and what the square root of 32 is. So just down kind of underneath, and do the square root of 8 and the square root of 32. So 8, 1 times 8, or 2 times 4. That's our only options, so it's going to be the square root of 4 times 2. So that is, the square root of 4 is 2, that's 2 root 2. And then 32, we would have 1 times 32, and we'd have 2 times 16, so we've got our 16. So we would have the square root of 16 times 2. So the square root of 16 is 4, the square root of 2 just stays like that. So we end up with 2 root 2 plus 4 root 2. Okay, and a little hint for these ones. If you end up with something under your square root that's not the same. So if we look at these here, give me a second, not what I'm looking for, this one. If we look at here, we've got a root 2 and we have a root 2. So those need to be the same for us to be able to add them. So if the question's asking you to add these, it means that you've got to be looking for the number under the square root to be the same for both of them. So if I have 2 square root of 2's and I add another 4 square root of 2's, I have 6 square root of 2's. Just treat the square root of 2 like an object or a variable in algebra, so it's kind of like x, so it's like 2x plus 4x, we know that's 6x, but instead of an x it's the square root of 2. Right, so for h we've got the square root of 27 minus the square root of 3. So we know the square root of 3 is as simple as that surd can be. There's nothing we can do with the 3. So that means the 27, to be able to take that away, we need to change it into something root 3. And, coincidentally, we've got the square root of 27 up here for part C. So we know the square root of 27 is 3 root 3, so we can just take that down. We don't have to do it again, because we know that it's 3 root 3. And then we've got to take away the square root of 3. So we're going to get 3 root 3, take away 1 root 3. So that gives us 2 root 3. Right, on to question 2. Right, so question 2. Part A, we've got the square root of 50 plus the square root of 32. The question says to leave them in the form a square root of b. So that just means simplify them and put them together into one expression. So, square root of 50. 50, we'll look at it again. 1 times 50, 2 times 25. So, we've got 25. So, that one's going to be the square root of 25 times 2, which is going to be the square root of 25 is 5, and then we have the square root of 2. And we look at our 32 next. So the 32, we have 1 times 32, and we have 2 times 16. So 16 is our square number. So we have 16 times 2. So we have 4 root 2. So then we've got 5 root 2, add another 4 root 2. So we have 9 root 2's. Okay, so here we have, for part B, it's kind of like what I was talking about with question 1. You've got 5 root 3, take away the square root of 27. So we can only take away things that have the same number under the square root. So that means we have to change that 27 into 3 times something. So 27 is 3 times 9. Okay, and because we've got a square number, we're good. So we're going to have 5 root 3 just stays as it is, minus, and then we've got the square root of 9 times 3. Always put the square number first, remember. So you get 5 root 3, take away, square root of 9 is 3, and then times root 3, 3 root 3. So we've got 5 of something, we take 3 of them away, we're left with 2 of that something, and that something happens to be root 3. Okay, so on to question 3. Okay, so we're on to question 3. So we have the square root of 17 squared. So squared just means times by itself, okay? So we have the square root of 17 times by the square root of 17. And one of our rules that we know about surds is that if we take something that's square root of anything, so like the square root of a times by the square root of a, that's just equal to a. So if it's the same square root, the same surd times by itself, you just get what's under the bracket. So the square root of 17 times the square root of 17 just gives us 17. Right, so part B. Again, so we've got 2 root 3, not 2 root 3, 2 root 2, times by 2 root 2. Okay, this one's not quite so simple. So if we split it down, it's like 2 times root 2 times by 2 times by root 2. So we've got a root 2 times a root 2. So these two here, root 2 times root 2 gives us 2. Yeah? From this rule here, root something times root something equals that. And remember, like multiplying, we can do it in any order. It doesn't matter, we'll still get the same answer. So if we multiply those out, you get 2 times 2 times 2. Because the 2's, that one's just come straight down, that one's come straight down. and then the square root of 2 times the square root of 2 becomes 2. So we have 2 times 2 times 2, which is 8. Okay, so last one for question 3, we've got the square root of 2 cubed. So that's equal to the square root of 2 times by the square root of 2 times by the square root of 2, because the 3 is telling us that it's 3 root 2's all multiplied together. So the square root of 2 times the square root of 2 just becomes, let these two come down and just become a 2, and then we've got to times it by the square root of 2, so it's 2 square root of 2. Okay, so on to question 4. So question 4, it's all about rationalising the denominator. So that's where we take the surd off the bottom of the fraction and we just leave a number with no surd on the bottom. So here we've got 1 over root 3. To get rid of that on the bottom, we're using the same rules as the last one, so the kind of root a times root a equals a. So to get rid of that, we need to, not equals, need to multiply the bottom by root 3, and to keep the fraction the same, we have to multiply the top by the same. So on the top you've got 1 times root 3, which is just root 3. On the bottom we've got root 3 times root 3, which gives us 3, and that's us. So the next one, we've got 10 divided by root 5, so we need to multiply the bottom by root 5, so that means we have to multiply the top by root 5 as well. So then we get 10 root 5 divided by 5. So now we've got a 10 on the top and a 5 on the bottom, so the 10 and the 5, they're in the same times table. 5 is 1, 10 is 2, so it's the same as just 2. 10 divided by 5 is 2. So you get 2 root 5, and it would be over 1, but when something's over 1 we just leave it as it is, we don't need that. And then our last one, we've got 6 over root 2, and we're going to have to times the bottom by root 2, which means we have to times the top by root 2 as well. So we're going to get 6 root 2 over 2, because root 2 times root 2 is just 2. And then again we can cancel down because we've got a 6 and a 2. 6 divided by 2, that's a 3, and the bottom goes a 1. So we just end up with 3 root 2. Okay, so question 5. Right, so question 5 is a bit more difficult. It's not just kind of working with the surds, it's bringing in our extra things that we know. So something is missing from a diagram, which would be the right angle. So we've got to find the length AC, leaving our answer as a surd in its simplest form. So we've got a right angle triangle, we know 2 sides, we need to find the other one. That means our favourite, Pythagoras. Okay, so if we look at our thing, we go across from the right angle, that gives us our hypotenuse, and then we label the other sides A and B. So because we're finding the short side, B, which is AC, that means we're going to have to take away. So AC squared, I've just put in AC instead of B, is equal to the hypotenuse, which is AB, and then that's squared, take away the other side, which is BC, squared. So AB is the square root of 50, and I'm going to have to square that. Take away the square root of 32 squared. So by now we should know if we take something under a square root and we square it, those are like adding and subtracting, multiplying, dividing, they're the opposites of each other, so they cancel out. So the square root and the square cancel out, so we get 50 just on its own, and square root of 32 squared is just 32. So we get that AC squared is 50 minus 32, so it's 18. So then to get AC on its own, we have to take the square root, so we get the square root of 18. So now, because it said the surd in its simplest form, 18. We've got 1 times 18, we have 2 times 9, so we've got our surds. So we have the square root of 9 times 2, so the square root of 9 is 3, and the square root of 2 just stays as it is, and that's us. AC, in its simplest form, is 3 root 2. Okay, we're almost there. Last question, question 6. This is another one of expressing with a rational denominator, so that means getting rid of the surd on the bottom. So we have 1 over root 2. We've got to times that by Bottom has to be times by root 2, so does the top. So we get the square root of 2 over 2. Next one, we have 2 over root 5. To get rid of the root 5 on the bottom, we need to times that by the square root of 5. So that means we have to times the top by the square root of 5 too. So then we get 2 root 5 over 5. 2 and 5 aren't in the same times table, so nothing we can cancel there. Right, so C. You might be tempted to just make that the square root of 8 over the square root of 24. 24, not 4. But we can simplify before we do anything. So 8 and 24, they're both in the 3 times table, and they're also both in the 8 times table. They're not both in the 3 times table, they're both in the 8 times table. So 8 becomes a 1, 24 becomes a 3, so we can say that's the same as the square root of 1/3. So then we get the square root of 1 divided by the square root of 3. So we've got 1 over root 3. And then to rationalise the denominator, we need to times the bottom by root 3. So we have to times the top by root 3 too. So we get root 3 over 3, and that's us. Okay, so if you've got any questions, feel free to ask in class or write in the comments. Thanks for watching, and hopefully this has helped you understand surds a bit better.